Welcome to Techie Mom channel. Subscribe for more updates. Today I'll be explaining how higher order functions will be working in Swift and we'll see what are higher order functions. Higher order functions are nothing but simply functions which takes one or more functions as an argument or returns function. Swift has some higher order functions sorted, map, filter and reduce. We'll discuss about sorted now, which is basically sorts the elements of the array. So here I'm taking an array of strings which contains both lowercase and uppercase strings. By default, sorted function will sort the array ascending order. So let's create the array of sorted data of int array. Okay. Now both int array and string arrays are created. Now let's just print and check how sorted will work. Yes, now it is printing. You can see basically first it is taking uppercase and then lowercase in ascending order. So the numbers are in ascending order. So sorted will basically do the sorting in ascending order by default. Now just change the uppercase string to the lowercase string and just run it and check. Yes, now the string array is totally in ascending order. Now let's print how to sort data in descending order. So I'm just calling sort data dot sorted by. Here we need to pass a closer as an input, or you can use shorthand arguments. Shorthand arguments are nothing but the $0 or $1 we'll be using. So here I'm just sorting both the strings. I had named A and B as the strings for the closer and just returning A greater than B, which returns the descending order of the data. The same way I'm doing with the integer array as well. So now you can see the data is printed in the descending order. So while passing closer to the sorted, you can write whatever logic you want and however you want the output to be displayed. So based on that, you need to make the arguments to work. Here directly, instead of passing the closer, I have passed the operator which is greater than directly. So even that will give the same result as the top closer. So now let's see what exactly greater than is. When you check the definition of it, you can see the closer related to the operand. This is we call passing an operand to the higher order function, which is nothing but the equal to passing it closer to it internally. So the same way there are different operators like greater than or equal to, less than or equal to, or multiplication. So we can directly use the respective operator instead of passing the closer. Now let's see what else we can do in the closer operations. Here I'm sorting array based on the multiple of number 2. So first it will show the even numbers and then odd numbers. So this is how I have been sorting the arrays in different ways. So let's see how filter will be working. Filter is nothing but filtering the array based on the conditions we require and getting the required information from the given array. So I'm creating a struct of a person which contains parameters name, age and location. So I'm just creating another variable which is array of persons. So I'm just adding the person objects to the persons array. In the same way, I'm creating multiple person objects and adding to the persons array. So now let's print and check how the array looks like. Oops, now you can see the data, but in playground you can see LLDB expression warning. And now let's print the filter data. Here I'm filtering the person's array where age is less than 30. So just print and check filter data as well. Oops. When I'm printing both the datas, you can see LLDB expression warning. So let's see how to fix this first. In playground, when you try to print a structure class which is doesn't having any superclass, then you will be getting this warning. So now I'm extending the protocol custom string convertible and overriding the description parameter which returns the parameters which we have in the person, nothing but the name, age and location. I'm returning as a single string. Now just run and check. Yes, now the data is printing properly. Now the top data is the whole array and the bottom one is the filtered array which has the age is less than 30. Now just change the age to greater than 30 and see the results. Like this you can change the conditions, based on that you can filter the existing array. Now let's see how map will be working. Map is nothing but the modifying the elements of an array. Here I have taken the same data of persons. So I would like to get an array of only the names of the persons. So in the closure I'm passing shorthand argument which is nothing but directly using $0 for the respective element instead of passing the closure. This will return the only names array which I want. So now let's see how to return multiple values of the struct. So I'm just returning tuple of name and age. So let's print and check. Now it is returning array of tuples and each tuple contains the person name and age. Like this, however we want, we can modify data and print it. So I'm just appending a specific string to all the names and just printing. Now you can see the names array where each and every name postfixing with the specific string. Maps are basically different types like the normal map, compact map and flat map. Let's see how those will be working. I have created an array of strings. The strings contain both the digits and characters. Now let's just print the array using map, and I'm converting each element to integer now. Now you can see for the strings it is giving nil and for the integers it is giving optional. So map basically modify the elements but it returns the optional and nil values as well. Now let's see how compact map works. The same integer conversion I'm doing here. Now you can see the result array which doesn't having any optional values. So the difference is compact map totally removes the null values. And now let's see how flat map works. The same operation I'm doing here, like converting to string. So I'm getting warning like flat map is deprecated. Please use compact map for the case where closure returns an optional value. Now let's see what is exactly flat map. Flat map is nothing but which really flattens the arrays. Let's take an array which is combination of int arrays. So it is arrays of arrays. So when I try to flatten this array, we'll be using flat map. So I have created array with int arrays here. I'm just printing map data dot flat map. I always prefer to use shorthand arguments which are easy to use. Even you can use closures as well. So I'm just printing the data here. So which actually combines all the elements irrespective of different arrays. So which really flattens the array of arrays and gives the single array as an output. Even reduce performs the same kind of operations which combines the elements of the array and return an object. Now let's see how to return the same data using reduce function. So I'll be calling reduce. Here we need to pass initial result and partial result. Initial result is nothing but the initial object type and the partial result is the operand which we need to perform. So when you pass initial result as an empty array and partial result is plus, it gives the same result as flat map. So I'm just assigning the same flat map value to the flattened data. So let's do some more operations with the reduce function here. So here the flattened data is array of ints. To the reduce function, I'm passing initial result as 0 and partial as plus. So what it basically do is it will sum up all the integers in the respective array. Now let's pass 3 and check how it works. So what basically it does is initial result and the operator which we do. So 3 plus the sum of the elements in the array it does. The same way when I pass the minus operator, it does the operation 3 minus the minus of all the operators. The same with the multiplication operator. Now let's pass 0 and multiplication operator and the output is 0 because what it does is the initial result and the operator which we pass it work in that way. So now let's see what exactly in the reduce function. So when you go to the definition, you can see the initial result and the next, nothing but the partial result. So here directly we can pass the shorthand arguments or closure as we discussed earlier. So the initial result I'm giving item 1 and the partial result I'm giving item 2. I'm just giving the multiplication of the both. So it gives the same result as the top reduce where I have passed 1 and multiplication symbol, because the multiplication symbol inbuilt is having the closure like we have discussed before. So always try to use the crispy operators. Hope this is helpful. Please like, share and subscribe Techie Mom channel. For more notifications, click on the bell icon.